Hey guys, this is Mrs. Harmon, and this is Algebra 2, Section 1.7, Compound Inequalities. Last presentation, we talked about inequality symbols, how to graph inequalities, and how to find solutions for inequalities. Today we're going to look at compound inequalities. Our biblical correlation comes from Genesis 6:15 and 16, where God tells Noah how to build the ark. And we see this concept of measuring and precision early on. And we know that God gave us the skills of math to keep things orderly and organized and precise. And we need to use these skills to take care of His creation in a way that is orderly and organized. Our lesson objective is this. The student, you, will solve and graph compound inequalities and write and solve compound linear inequalities. A compound inequality combines two inequalities into one statement. There are two kinds of compound inequalities, conjunctions and disjunctions. A conjunction combines two inequalities with the word and or the symbol that looks like a caret, kind of like a capital A. It is the intersection of the inequalities' solutions. So if we were to graph both inequalities, it's where they intersect. It's what they have in common. Again, we represent that with this symbol that looks kind of like an A for and. That is a conjunction. A disjunction combines the two inequalities with the word or the symbol that looks like a V. It is the union of the inequalities' solutions. Thinking back to a Venn diagram, when we used to graph things in a Venn diagram, the overlapping part, what they have in common, that would be like your conjunction between your two inequalities. And then the totality of the two circles, everything that's in the two circles, that would be your union of your two inequalities. Let's take a look at this example. We've solved 5x plus 9 is less than or equal to 24 and negative 3 minus 7 is greater than 14. So this is a conjunction. We're worried about where the two overlap, like in a Venn diagram. First, let's take a look at 5x plus 9 is less than or equal to 24. If we solve for x, we get x is less than or equal to 3. On our other inequality, when we solve for x, we get x is less than negative 7. On our number line, we can see x is less than or equal to 3 is graphed in red, and x is less than negative 7 is graphed in blue here. And the part that they have in common is graphed in purple. Their overlapping parts are graphed in purple on the number line. X is less than negative 7. Take a look at this example and see if you can figure this one out. First, we've got 8 is less than 5x minus 7. But notice this 5x minus 7 is a part of both inequalities. We're going to use that twice. In the first inequality, when we solve for x, we get x is greater than 3. In the second inequality, when we solve for x, we get x is less than 5. We're going to graph the red at the top, x is greater than 3. The blue in the middle, x is less than 5. And their intersection, or where they overlap, is between 3 and 5. We write that as x is greater than 3, but less than 5. We put that x in the middle and show that x is greater than 3, or 3 is less than x, and x is less than 5. Pause the video, try this one on your own, and then come back and check your solution. And in this case, we're looking for an or. Remember, or was the union of both of these inequalities. Once we solve for x's, then we're going to graph. X is greater than 6 is over here in red on the right, and x is less than or equal to negative 5 is over here on the left in blue. And the union is both of the pieces put together. So we have to have this purple part here and this purple part here. And that shows our union of the two sets. And our answer then would be x is less than or equal to negative 5 or x is greater than 6. The result of solving a compound inequality may be that there are no solutions, or that the solution set is the entire set of real numbers. We saw that when we were graphing just regular inequalities, and the same holds true for compound inequalities. Take a look at this example. Do this. First, simplify. Then graph. Then make a final statement. When we simplify, we're solving for x here, and we're solving for x here. Here is our intersection, or and. We get x is less than -5, and x is greater than 1. When we graph those and we're looking for the intersection, we see there is no intersection. They don't cross paths at all, so there are no solutions in this compound inequality. This time, we are looking for the union. So all of the parts covered by these two inequalities. When we solve for x, we get x is greater than or equal to -5, or x is less than or equal to 1. When we graph this, we see our top one goes to the right for infinity, and the bottom one, x is less than or equal to 1, goes to the left infinitely. Because they both go on to infinity, both left and right, our solution set is all real numbers. Take a look at this application example. Carrie has received scores of 79, 87, and 95 on her first 3 tests. What scores could she receive on her next test and maintain the B test average? Anywhere between 80 and 90 would be a B. Well, we know that 79, 87, 95, and some score divided by 4 will give us her test average. And we know that we want that number to be greater than or equal to 80 or less than 90 to maintain that B average. We set this up as a compound inequality and solve for t. And when we do, we find that t has to be greater than or equal to 59 or less than 99. So if Carrie receives anywhere between a 59 and 99, she will maintain her B test average. This might be a great problem for you guys when you're trying to figure out your midterm and final scores at the end of the year. You're trying to figure out what grade you have to get on your midterm in order to maintain a certain report card grade. All right, that's it for today. If you guys have any questions, be sure to ask me next class.